Now that we've talked about many of the concurrency and parallelism concepts and mechanisms, frameworks, and so on that are available in Java, let's kind of take a step back and evaluate them with an eye towards trying to determine which ones are the best to choose under which circumstances. So this is something that confronts anybody who goes out in the workforce. At some point, you'll get to a stage where you have to be able to explain to people why you made the choices you made. Why did you decide to use completable futures rather than parallel streams? Or why did you decide to use Java executive framework versus reactive streams? What was the rationale behind what you're doing? As we've seen, Java's concurrency and parallelism mechanisms span multiple layers in the software stack. And I've kind of talked about this at a high level, but I think it's worth going through in a little bit of detail. In particular, this is what will help us understand which of these levels to choose under which circumstances. So if you take a look at kind of the classic Java stuff, actually the very classic Java stuff actually appears in the virtual machine level. So this is the layer here, the one that says execution environment. So that would be things like Java threads and Java synchronizers, the simple ones like the built-in monitor objects. Those have been around since day one. Very, very low level. Prefer not to use those unless for some horrible reason you're stuck using Java 1 in your job, right? You have legacy commitments to Java 1, which would be a bad thing. More likely, this is a very common thing, a lot of people are programming to Java 5 era stuff. This would be things like what you would find in Java util concurrent. So executor framework, classes, reentrant lock, condition object, semaphore, countdown latch, cyclic barrier, all of these different kinds of things. And those are what are often referred to as the shared object mechanisms. There's also some stuff in there about message passing, but a lot of the low-level things like reentrant lock and condition object and semaphore are about having multiple threads coordinate each other using these shared synchronizer objects. So that's kind of the classic old school way of doing things. And the good part is it's very efficient, very lightweight. These mechanisms have been tuned quite a bit over time. The problem is that it's tedious and error prone to program at this level. There's lots of accidental complexity at this level. You have to wrestle with complicated things, and if you forget to lock or unlock in the right place, your code doesn't work anymore, and so on. So shared object style programming is typically used primarily by infrastructure developers, people who are building higher level frameworks, as opposed to application or app developers. App developers really don't want to have to think about this kind of stuff. They want to focus on whatever they're doing for their domain, for their customer. They don't want to get wrapped around the axle of these tedious and error-prone, low-level mechanisms, even though they're important to exist. And you'll see the later stuff that's higher level uses these things. We'd really like to shield the application developers from this as much as possible. The next set of things are there's a bunch of frameworks. So we have frameworks that exist like Java Executor Completion Service, Java Executor Service, various mechanisms that are part of Java 5. Android has a bunch of things called async tasks in older versions, or the Android handlers, messages, and runnables framework, the so-called Hammer framework. And these basically communicate by passing messages from one thread to other threads or another thread. So that's another way of doing processing. And under the hood, they're typically using stuff like array blocking queue or linked blocking queue, which are part of Java 5's abstractions that they give you. So the good part about message passing is it's flexible and decoupled. You don't really have to know about locks or synchronizers. You just create a message in one thread and you say, send it. It goes to another thread. The other thread takes it. It doesn't really have to know about locking or coordination or visibility or all these other kinds of complicated low-level things. So that's good. The downside is that there's some time-space overhead moving information or data or messages from one thread to another thread. So there could be higher context switching overhead of moving from one thread to another, higher synchronization overhead, higher data movement overhead, and so on and so forth. So again, pros and cons, right? You have to figure out what you want to do. The third level we're going to talk about here are the higher level frameworks, which are what we would call sort of application frameworks. These are things that don't really come with the low level stuff that's in Java. This is more the things that got added later. So these would be parts like Java streams, parallel streams, completable futures, reactive streams, and then things that build on top of that, like RxJava, Project Reactor. That's typically what application developers would prefer to use if they're using concurrency, of course, or parallelism. And that's because most of the details are pushed down, so you don't have to think about creating a thread or acquiring and releasing a lock or synchronizing, all those things, or barrier synchronizers. All that stuff is handled for you by the higher level frameworks. The good part about this is it's much more productive once you master the learning curve, much more robust once you manage to master the learning curve. But there could be additional overhead. Anytime you add layers of stuff, it's going to make things perhaps a little slower. Maybe the win is because you can run things in parallel, you often get back a win because even though you have micro level inefficiencies, you're running more things in parallel, and so you get a macro level speed up. And the other thing that might be a problem is these frameworks are a bit overly prescriptive. They want to have a certain computational model for your program, and if your program conforms to that computational model, like divide and conquer with parallel streams, life is good. If your program and the way it's trying to do its processing doesn't conform very well to that model, then it may be a bit of a mismatch, or what we sometimes call a Procrustean bed, where you stretch things or chop things up in order to make them fit, and they're not quite optimized. If you really want to be a full stack developer, then it's important to be fluent with all these different layers. You don't have to be a full stack developer at this point in your life, but over time you might want to get more facile and more informed about these different layers. And so this class will teach you about some of the layers. We'll be talking primarily about sort of the higher layer stuff. And then my sibling class in the spring will talk about some of the lower layers. And this is probably the right way to do that. So this way, if you take this class first, you get the big picture view, you see how things work sort of from a more abstract point of view. And then if you think that's interesting, you can kind of dive down into the more detailed stuff to see how it works under the hood. So regardless of which Java programming mechanisms you select, be prepared to master the inherent and accidental complexities of concurrent and parallel programs. So this is a great quote. It says, I'm sure you've all heard the phrase, insanity is doing the same thing over and over again and expecting different results. Right? That's the thing. Well, this is the concurrency and parallelism view of that. It says, whoever said the definition of insanity is doing the same thing over and over again but expecting different results wasn't debugging concurrency machines. Because what you'll find is that you do the same thing over and over again and you get different results each time, because concurrency and parallelism are inherently non-deterministic. So I don't know, I just thought that was a clever little play on words that fits in nicely with this meme. So that's the end of the overview of evaluating concurrency and parallelism mechanisms in Java.